Okay, so again, this is a lot of review today from Algebra 1, so I am going to go over this kind of quickly. If you need me to explain something again, just let me know. So the main thing that we're going to talk about today are different ways to graph linear functions. So when you're doing your homework, make sure you're paying attention. So some of them are going to say to use a table. If you are using a table, that means you need to have an XY table, and we're going to be putting 5 points on there. Now the simplest way to do this is to put the equation in the y equals mx plus b form. And sometimes it's already in that form, like this one almost is, it's just the y's on the other side. So you can just write it as y equals 4x minus 2. And then if you're using a table, I just want you to have 5 points in your table. So this will be the same thing with your homework. Okay, so if you want the full credit for that, you just have to do your table with 5 points. And, and then we're going to graph. All right, so when you're doing your table, are there any x values that you remember using in previous years? So that's going to, if you move it over, yep, you could subtract that and subtract this to this side, but you'd still have the y. So you'd have to subtract the y on the other side, and then you'd have to divide by a negative, and then it would match mine. Okay, so your table with 5 points, okay, you can always put 0 in the middle. So if you put 0 in the middle, that's going to be your y-intercept. Okay, and then, so you have the 0, negative 2, and then once you do that, it's very common to use negative 2, negative 1, 0, 1, 2. Do you guys remember that from Algebra 1? Okay, so those are very common values. You're welcome to use those most of the time. And then to find your y value, if you know what you want the x to be, all we have to do is plug it in. So it will be 4 times 2 minus 2. 4 times 1 minus 2. 4 times negative 1 minus 2. So you're just plugging them in for x. Okay, now when you're doing this part on your homework, I know that many of you can do this in your head. That's fine. I just want you to write it out for your notes so you know where those are coming from. So negative 8 minus 2 will be negative 10. Negative 4 minus 2 is negative 6. And then you can also use your pattern. Like, what is happening here with those numbers? Yeah, with the 4? What's happening? Every single time it's increasing by 4 because 4 is the what? The slope, right? So if your slope is 4, this is negative 10. Just add 4, add 4, add 4, add 4. Okay, and you can use that as well. Okay, so you don't have to show this work. I'm just showing you that that's where those points are coming from. And then we are going to plot those points and then connect with a straight edge. So we have negative 2, negative 10, negative 1, negative 6, 0, negative 2, 1, 2, and 2, 6. Okay, so you're going to take the straight edge that you have from today. And we are going to have time to work on our homework today, so you can use this. If you're at home and you don't have a ruler, you can also just use like a note card or the side of a Post-it note. All right, and then for part B, we're going to put that in the form y equals mx plus b. So this time, the y and the x are on the same side. So we're going to have to subtract that over. So if we subtract 3x from both sides, this is y equals negative 3x plus 1. Okay, and then we're going to make our table. Okay, and then when you are graphing, so I always say like my third step is to graph, just make sure that you span the grid. I'm going to give you a graph sheet today. Anytime you're graphing on your homework, you need to make sure that you use graph paper. Okay, so we're going to span the grid. So if you're doing this, we know that at 0, it should be your y-intercept, right? We know that already, that this should be 0, 1. You could also plug it in. Okay, and then maybe we want to see what happens when we plug in 1. Again, this is what I'm doing in my head. I'm multiplying and then adding 1. Okay, and if I want to span the grid, I don't have to do 0, 1, 2 every time. Maybe I want to jump to 3. That's fine. So I do -3 times 3 plus 1. That will give me -8. And it doesn't matter to me what your x values are as long as you have 5 of them in your graph. You just need 5 points in your table. Okay, and remember when you plug in a negative, when you're multiplying, what happens when you do a negative times a negative? Comes a positive. So 3 plus 1 is going to be 4. Okay, -3 times -3 is 9. 9 plus 1 is 10. And then we can just plot our points, connect with our straight edge. Okay, so we take a minute now to do that. One thing you might want to check is when you are graphing, once you have graphed it, if you have a negative slope, what direction should the line be going from left to right? Yep, it should be going down. So if it's negative, it should be going down. If it's positive, it should be going up. Okay, so it's just those 1, 2, 3 steps, okay? All right, now the second way that you have graphed lines before is by using the x and the y intercepts. And you could put this in y equals mx plus b form to find the y-intercept right away. You absolutely could do that, but there's another thing that you could do as well. For every x-intercept, what do we know about the point? For every single x-intercept, the y is 0. So to find the x-intercept, you can plug in y is 0, and then what you end up doing is solving for x. So you can plug in y equals 0 and solve for x. All right, so let's do that. So if this is my equation, y minus x equals -3. If I plug in 0, I end up with -x equals -3. And then if I want positive x, what would I do to both sides? Yep, you can multiply both sides by -1. You can divide both sides by -1. Remember, whatever I'm writing down for my notes, you should have that written down as well. Okay, so we're going to plot 3, 0. So 3, 0, x-intercept, it's on the x-axis. All right, and then to find the y-intercept, that's where you can plug in x equals 0, and then you would solve for y. Okay, so you can plug in x equals 0, and you can solve that for y. So again, we're going to take this. So this would be y minus 0 equals -3. Well, what's y minus 0? It's just y. Okay, so then this is my intercept, so you would be plotting 0, -3. So with this, because it's telling you to graph using the x and the y intercept, You are just going to plot those 2 points, and then you are going to connect them with your straight edge. That's all you have to do. Okay, and again, we're just going to span the grid. So that means I'm going from left to right. You're just going to span whatever grid you are given. Okay? All right, and then for example 3, we're going to change some things up a little bit. So if you're working ahead, please don't work too far ahead of me. There are just specific things that I'm going to want to tell you to do. Okay, so this is where you're going to graph each equation by using M and B. And this is usually the one that people remember the most, because we know that M is the what? Not the F. What do we call it? No? Slope. M is the slope. B is the y-intercept. Yep. So whenever you are graphing, okay, where do you start? If you have it in this form. So we're hesitating. Start at, do we know where to start? Yeah, start at the y-intercept, okay? And not 0, 0. So the only time you would start at 0, 0 is if that was the y-intercept. Bless you. So your y-intercept is your b value. So if b equals 12, you're going to start at 0, 12. Now, bless you, I shouldn't have given you a graph with that was labeled for this, because then you'd have to start off here. The graphs I gave you for your homework are not labeled, and so we're going to scale this by something different. So this was scaled by 1s. We're going to go ahead and we're going to scale the y by 2s. Okay, so we're going to scale the y's by 2s, and then we're going to leave the x's scaled by 1s. So if you scale by 2, then this would be 2, 4, 6, 8, 10, 12. And then I just usually label a couple of these. Okay, so we're going to put our point at 0, 12. Okay, so we changed the scale to make sure that we could fit this on there. Okay, so I don't want you to say, oh, I couldn't fit it on the graph. Just change your scale if you need to. Okay? All right, and then your second step is going to be to use that slope. When you're using the slope, you have to remember that your slope is the rise over the run. So in this case, our slope is negative 5/3. When you have a negative, you can apply it to either the numerator or the denominator. I always apply mine to the numerator because I think that's easier to just have that process. So if you have a negative and it's on the rise, that means you're going down. If it was positive, you would go up. So this means you go down 5, and then the bottom is right 3. When you're doing that process, you want to make sure if you have a negative slope, it is going down from left to right. Now, because we have an odd number here, 5, just be careful with your counting, okay? So we're going to go down 5. So this is 1, 2, 3, 4, and then 5 would be halfway, and then over 1, 2, 3. And then down 5, so this would be 1, 2, 3, 4, 5, 1, 2, 3, and just continue that process. So 2, 4, 5, 1, 2, 3. Now you can also go the alternate way. So instead of going down 5, right 3, you could go up 5 and then go left 3. So if you went up 5, 2, 4, 5, 1, 2, 3. Okay, and then you can connect those points. So again, I try to do 5 points on there. You want to span your grid. You want it to be as accurate as possible. And notice that if you do line up your straight edge, you aren't hitting all your points, you may have made a small mistake, so you definitely want to check that. All right, so I'll give you a moment now to just make sure that you went down 5 over 3. Next one is the straight edge. It should span the grid all the way. Okay, so some of you don't have it going past the 2 axes. It should be going through the y-axis. It should be going through the x-axis. All right, and then the last thing we're going to do today is graph inequalities. Do you guys remember anything about graphing inequalities? Right, an inequality is going to have either a greater than equal to symbol or a less than equal to, greater than or less than. Okay, and then this is where you have to shade. So with inequalities, it's a little bit different than if you just have an equal sign, right? If you have x equals a value, that's just one value. But if you have x is greater than or equal to 3, that's going to be an infinite amount of values. So we show that using shading. And then your boundary line can either be solid or dashed. Do you guys remember how to determine if it's solid or dashed? Yeah, if it's not true or not true, but if it's, yeah, if you have the equal to, so if it's solid if you have the equal to symbol, so it can be greater than equal to or less than equal to. It'll be dashed if it's greater than or less than. So it's always dependent on that symbol. Okay, now, do you guys remember how you can check where to shade? You use what's called a test point, and often your test point would have been 0, 0. And then you see whether it's true or false. And then depending on that statement, that's going to tell you whether you shade above the line or below the line. Okay, so if your statement is true, then you are going to shade that region. And the region is going to change depending on what your line looks like. And then if it is false, you are going to shade the opposite region. Okay, so if it's true, you want to shade it. If it's false, you want to shade away from it. Okay, and we're going to use some of the same concepts that we did in example 3. All right, so the first thing that we want to do is to make sure that we have that line in y equals mx plus b form. Because then we can do exactly what we did in example 3. And we're going to graph the line. Okay, so if it's in that form, then we can do the graph. All right, and then we're going to identify the type of line it is. So we're going to identify if it's solid or dashed. That's an easy mistake to make because we're so used to graphing solid lines. Okay, so make sure that you check that. And then our third step is going to be the test point. Okay, so the most common test point that we use is 0, 0. And the test point is going to tell you, confirm where you need to shade. Now, sometimes it's really simple to determine where to shade, so we're going to talk about that too. And then when you are using your test point, you're going to use 0, 0 unless it's a point on the line. That's the only time you can't use it is if it's on the boundary line. So we're always going to use 0, 0 unless it's a point on the line. Okay, and then you wouldn't be able to use that. All right, so this is graph each inequality, and you have y minus 7 is less than or equal to negative 9. So if I want that in the form y equals mx plus b, and really we said it equals, but it's going to be an inequality symbol, okay? So we're going to move over that negative 7, and then because these are like terms, we can add them together. Okay, so this is going to be y is less than or equal to negative 2, and this is what we're going to graph. Okay, so we want it in that form. And then, like I said, we can use what we did for example 3. So what's your y-intercept there? No? Yeah, so the point would be 0, negative 2, right? This is your b value. How do you know that's not the slope? What does the slope always have with it? The x. So your slope in this case is there an x there? Nope, so it's 0. Okay, this is a special type of line. Do you guys know what type of line it is? Yep, horizontal. So if you're at negative 2 here, right, this is a horizontal line. And then is it going to be solid or dashed? Solid. So you have the equal to, so it'll be solid. Okay, so I graph my y-intercept. You rise over run. If 0's on the top, you aren't going anywhere up or down. So it's just a straight line here. Now, sometimes, like when you have a horizontal line, it's very simple to tell where to shade because it says y is less than or equal to negative 2. Where are all the values that are less than negative 2? Below. So if it's a horizontal line, a test point is not something that you would have to show like on your homework. We're going to do it together for this one so you can see how it works. Okay, so we're just going to shade below there. Okay, and then if you did your test point, 0, 0 is not on the line, so you can test it. I usually just mark it there. Okay, and it's not shaded. So keep that in mind. And then we're just going to plug it into our inequality. So when I say plug it in, remember, every point is an x point and a y point. If there's no x, you just don't plug that one in. Your y value is 0, and then you just have to say whether this is true or false. So remember when you were first learning about these and your teacher probably said, oh, the alligator eats the bigger number? Right? Its mouth is going to eat the bigger number. So is negative 2 bigger than 0?
Yeah. No.
No. 0 is bigger than any negative number. Okay, so it's false. So anytime it's false, you do not shade that point. So you do not shade 0, 0. And if you look above, that's exactly what happened, right? We did not shade where the point is. We had to shade the opposite region. The points above, you would shade below. Okay, now on your homework, you might have a different type of line that's similar to this. So I just want to make a little note so you know what to do. So this is a horizontal line. Do you guys know what it looks like if you have a vertical line, what the equation would look like? Or can we guess based on what's happening with the horizontal? There would be no y. What would there be? There'd be an x. So you'd have something like x is less than or equal to, and it would be some constant term, which we'll just call c, some constant term c. Okay, and then that means that you would have a vertical line. Okay, so make sure you remember some of that stuff from Algebra 1. I know probably seems like a long time ago. All right, so for part B, there's not enough room here to solve, so let's do that over here. So step 1, I want you to do the first couple steps and put this in the form y equals mx plus b. Okay, if you can only do the first step, do that. All right, so what do we do first to put this in the proper form? What do you guys do? Yeah, move x to the other side, so we're just going to subtract x. Subtract x. Now, don't forget, you have this negative in front of y, so that's going to stay there. And when you're writing it in this form, you're just going to keep the x in front, keep the negative 4 behind. Okay, and then from there, you have to make this so that it is a positive y. So you can multiply or divide by a -1. But do you guys remember there's a special thing that happens with inequalities? Did you guys remember or no? It changes the values are going to change. Like this is going to become y. This flips, yeah. The sign switches. So a negative divided by a negative is a positive. But then don't forget to flip your sign. So let's make a little note about that. I think that's a very easy thing to forget. So note, switch the sign. When you divide or multiply, I'm going to use a star because some people think it's x. So if you multiply or divide by a negative, you do have to make sure you flip the sign. Okay, and then go ahead and use the process that we used for example 3 to graph your line. So start at your y-intercept, and then use your slope. Okay, so my y-intercept is 4, so I'm going to start at 4. Now my slope is 1, which I really like graphing, because if your slope is 1, what's your rise over your run? Just 1 over 1. Yeah, so you're just going up 1 over 1. And then what type of line are we going to have? A solid line or a dashed line? Which one and why? Okay, so anytime you don't have an equal to, it will be dashed. And so you just have to do like a little dash between them. And then you do have to put the arrows on both sides. So put an arrow here, put an arrow here. And then we're going to decide where we should shade. Okay, so again, you can use 0, 0 anytime it's not on the line. So I just mark off 0, 0 to make sure it's not on the line there. And you can plug it into the y equals mx plus b form, or if you wanted to plug it into the original, that would be an option too. It's just 0 goes in for x and 0 goes in for y. So 0 is less than 0 plus 4. And then you just have to determine, is it true or false? So the alligator's eating the 4. Is 4 bigger than 0?
Yeah.
Yes, so it is true. So that means you have to shade where 0, 0 is. So if I'm going to shade 0, 0, is it above the line or below the line? Below. So notice how that changes. Like here, 0, 0 was above the line. Here it's below. It's going to change just depending on what your line is. So you just have to pay attention to the position of it. Okay, and then we're going to shade everything underneath. This pencil is so good for shading. Just makes me happy. And are you doing art this year? Doing some shading and art yet?
That's the last.
You did? Oh, that sounds fun. Okay, and then like I said, I am giving you graph paper for this. Anytime you have to do graphs, you need to put it on graph paper.